All right, welcome Math 2 Geniuses. We are on Unit 5, assignment number 3. These are your notes. So this is in your packet. This will be page N3 for notes, page 3. And we're going to be going over the zero product property. Then we're going to be going over how to use that said zero product property to solve a quadratic equation. And then we are also going to be going over finding the coordinates of the vertex given the x-intercepts coordinates. Okay, now please watch this video carefully, as there's going to be a couple questions that I'm going to want you to write down throughout the video. So the zero product property. Okay, so here's what the zero product property says. It says that if A multiplied with B is equal to 0. So in other words, if I take two values, and it doesn't matter what the values are, we're going to call them A and B, then this zero product property says that A has to be equal to 0, or B has to be equal to 0. Okay? Simple. It's a simple property. So essentially what the zero product property is saying is that if you multiply two values together, and if the result of multiplying those two values together is equal to 0, then one of the values, either A or B in this case, has to be equal to 0. Okay? Now remember, the word or is inclusive, so that means that A or B, or actually both, could be equal to 0. Okay, let me give you another example of the zero product property. So if the quantity x plus A multiplied with the quantity x plus B is equal to 0. So once again, notice I am multiplying two values, one of the values being x plus A, the other value being x plus B, and I multiply those two values together, they are equal to A. Then the zero product property says that x plus A has to be equal to 0, or the x plus B quantity has to be equal to 0. Okay, so this would mean that x would have to be equal to negative A, or x would have to be equal to negative B. So remember, once again, if the zero product property is saying, if we're multiplying two quantities together, and those two quantities, when multiplied together, are equal to 0, it means either one or both of the quantities has to be equal to 0. Okay, the last example here of the zero product property. So let's say I have the quantity x minus 5, and I multiply it with the quantity x plus 4, and those two quantities, when multiplied together, is equal to 0. So according to the zero product property, this means that then x minus 5 quantity has to be equal to 0, or the quantity x plus 4 has to be equal to 0. Okay, so this would mean that x is going to be equal to positive 5. And why is that? Because 5 minus 5 is equal to 0. Or x is going to be equal to negative 4. All right? So this is telling me that x could be either one of those answers, or both of those answers right there. All right? So that is the zero product property, a pretty simple property. Now, we use the zero product property to solve a quadratic equation. Now, before we're going to go over how to use the zero product property to solve a quadratic equation, what I want you to do is, in your notes, I want you to put to the right of the Unit 5, notes assignment number 3, I want you to put a big number 1. I want you to put a big number 2. And next to the big number 1, I want you to write the answer to this question. So what letter in the alphabet does a parabola graph look like? Okay. What letter in the alphabet does a parabola graph look like? That's number 1. So next to the big number 1 in your notes, put the answer to that question. What letter in the alphabet does a parabola graph look like? Okay, all right, so back to assignment number 3. Use the zero product property to solve a quadratic equation. Okay, we're going to do 3 examples here. Number 1, so let's say I have the quantity x plus 2 is multiplied with the quantity x minus 5, and those two quantities, when multiplied together, is equal to 0. Okay, now we're going to be using the zero product property. Now, you can only use the zero product property if the quantities are actually being multiplied. They have to be equal to 0. So the result has to be equal to 0. Now, here's what the zero product property tells us. It tells us that for this solution, to solve this solution, this means that x plus 2, that quantity has to be equal to 0, or the other quantity, x minus 5, has to be equal to 0. So the zero product property tells us that one of those two or both of those properties has to be equal to 0. Now, what I do at this point is I solve each of these two equations out separately. So solving the x plus 2 equals 0 equation, I'm going to subtract 2 from both sides of the equation, and that means that x is equal to negative 2. Or solving the x minus 5 equals 0 equation, I would add 5 to both sides of the equation, and this means that x is equal to positive 5. So my solutions to this problem, x plus 2 multiplied with quantity x minus 5 equals 0, is that x is equal to negative 2 or x is equal to positive 5. And once again, the word or means it's inclusive, which means that my answer could be negative 2, or it could be positive 5, or it could actually be both negative 2 and positive 5. Okay, but in order to properly show your answer, to represent your answer, you have to show both solutions and put the word or in between them. Okay, number 2. How about if we have quantity x minus 8 multiplied with quantity 4x plus 7, and those two quantities, when multiplied together, is equal to 0. So we're going to solve this equation right here. Okay, now notice that I am telling you that these are quadratic equations. Now you might be a little bit confused because you go, Mr. Trutna, well, a quadratic equation I thought had to have the largest exponent being a 2. But if we multiplied these two quantities out, we would get an equation with the largest exponent is 2. Now, to solve this using the zero product property, and I can use the zero product property because this equation is equal to 0, it tells me, the zero product property tells me that the quantity x minus 8 is equal to 0, or the quantity 4x plus 7 is equal to 0. So either quantity is equal to 0. So then to solve, I solve each individual equation out. So solving x minus 8 equals 0, I'm going to add 8 to both sides of the equation. This is going to give me a solution of x is equal to 8. Or solving the other equation, 4x plus 7 equals 0, this is going to take me 2 steps to solve. My first step would be to subtract 7 from both sides, and then I would get the equation 4x is equal to negative 7, and then I would divide both sides by 4, and so I would get x is equal to negative 7/4. Okay, now if you wanted to leave that as a fraction, that's fine. Or if you wanted to divide it out and change it into a decimal, it would be negative 1.75. All right, so my solutions to this problem would be x is equal to 8 or negative 7/4. Okay, and that's how you could write your solution right there. Put the 8 put the word or, put the negative 7/4. Now what this is saying is that either one or both of these solutions, if I plug them back into the equation in the place of x, and then I multiply together, my equation is going to be equal to 0. Okay, number 3. How about this one? X squared plus 5x plus 6 is equal to 0. Now, this right here equation is more or less what we're used to seeing a quadratic equation look like. Okay, but if you notice, we're going to use the zero product property. Now, the zero product property only works if you have the two sets of parentheses. Okay, so what you're going to have to do in this problem is you are going to have to incorporate in the area model and the diamond problem, and then you're going to have to factor the x squared plus 5x plus 6 part, and watch what happens when I do that. So we're going to factor everything to the left of the equal sign. We're going to kind of leave the equals 0 part alone. So remember, we put the x squared in the top left of the area model. We take the 5x part, we put that in the bottom of the diamond problem. We take the positive 6, we put that in the bottom right of the area model. And then to factor out this equation, I multiply the x squared with the 6x, and that is equal to 6x squared. So I put that result at the top of my area model, and then I solve my diamond problem first, which means I would have to have, on the left and the right of the diamond, I would have to have 3x and 2x. I move the 3x and the 2x over to the two boxes in the area model, and then I fill out the outside top and the outside left of my area model, and those would be my factors. Okay, so let's start with the x squared. The only thing that you could get to multiply to make x squared would be x times x. So that's on my outside top and outside left. Okay, let's follow the x on the outside top down to the 3x. What would you multiply with x to make it equal to 3x? That'd be positive 3. So you write a positive 3 on the outside left. Now let's follow the x on the outside left over to the 2x. You would multiply positive 2 with that x to make it 2x. So we write an x plus 2 at the top of the outside top of my area model. So what this tells me is that my x squared plus 5x plus 6 part of my equation becomes quantity x plus 2 multiplied with quantity x plus 3, and then I bring in the equals 0 part. Okay, so this part right here that I just highlighted in yellow, and this part right here that I also highlighted in yellow, remember, even though these two expressions look differently, they are the same thing. Okay, so they are the same as each other. All right, and I know that because I just factored out x squared plus 5x plus 6. Now I'm going to go over to quantity x plus 2 multiplied with quantity x plus 3 equals 0, and I'm going to use the zero product property to solve this. So the zero product property tells me that the quantity x plus 2 is equal to 0, or the quantity x plus 3 is equal to 0. Either one of them is equal to 0, or both. And then I solve both equations to solve for my quadratic equation. Solving the first equation, I would subtract 2 from both sides. That gives me x is equal to negative 2. Or solving my other equation by subtracting 3 from both sides, that would give me x is equal to negative 3. So that brings up the point, what is my answer? Well, my answer is x is equal to negative 2 or negative 3, or both of them. Okay, so negative 2 or negative 3, or both of them. If I plug them back into either one of my equations, that would make the equations true, and that would be equal to 0. So that's how we use the zero product property to solve a quadratic equation. Okay, now let's go back up to the top. Number 2, you should have already written an answer for number 1. Now let's go to number 2. So next to the number 2, please write the answer to this question right here. A quadratic equation is an equation where the largest exponent is what number? So that is number 2. Pause the video, look at the question, and then go back to your notes, and next to number 2, write the answer to that question. Okay? All right, the last part of your notes here. Finding the coordinates of the vertex given the x-intercepts coordinates. So, I have the equation. Y is equal to x to the second power minus 6x plus 8 and this equation, the x-intercepts, are the points 2, 0 and 4, 0. Okay, and what we're going to do in this problem is we are going to find the coordinates of the vertex. Okay, so that's what we're doing. We're going to find the coordinates of the vertex. We know an equation, and we know we're also given the x-intercepts coordinates, okay? So here's the idea behind how to find the vertex if you know the x-intercepts coordinates, all right? So basically, this problem is telling me that when I graph this equation, y equals x squared minus 6x plus 8, now keep in mind that equation right there, that is a quadratic equation because the largest exponent is 2. So when I graph it, it will make a parabola, okay? And the x-intercepts have coordinates of -2, 0, which is, or +2, 0, and +4, 0. Okay, now, so essentially when I graph this, my parabola is going to look like something like this. And I'm just kind of showing you kind of like the general outline. All right, now we want to find the vertex of this parabola. All right, now the amazing thing about the vertex is that, remember, a parabola can always be split in half by what we call the line of symmetry. Okay, and your vertex is always on that line of symmetry. So in this particular graph right here, that vertex would be right there, okay? Now, there's something we know about that vertex, and the line of symmetry. The line of symmetry is always halfway between the two x-intercepts. So if you notice, so what that means is that this line of symmetry, it has to go through the x-axis at +3. So this line of symmetry has to go through the x-axis at +3. And the reason why that is because that is the exact +3 is halfway between 2 and 4, which are the x-intercepts right here. So what that tells me is that my vertex coordinates, the x value has to be 3, okay? And we know that because the vertex always lies on the line of symmetry. Now, in order to find the y coordinates of your vertex, what you do is you take your equation, y equals x squared minus 6x plus 8, and in this case, in the two places where there's an x in the equation, you substitute the number 3 into the equation. So that would make this equation y is equal to 3 squared minus 6 times 3 plus 8. Notice that in the two places where there was an x in the equation, I substituted the value of 3, and the value of 3 was the x coordinate for my vertex. And then I worked this out. Okay, so 3 squared, working this out, 3 to the second power is 9, minus 6 times 3 is 18, plus 8. Okay, working this out, this is equal to negative 1. So this tells me y is equal to negative 1. So the coordinates of the vertex are 3, negative 1. There we go. Unit 5, assignment number 3's notes by Mr. Trutna.